In this lesson, we're going to learn the different laws of exponents. And when we understand different mathematical laws, it helps us to be able to simplify expressions and solve equations. So we're going to learn the laws that'll help us with any expressions and equations that have exponents in them. So what are exponent expressions? They have two parts, a base and an exponent. Here's an example. We have 5 raised to the second power, or we can read this as 5 squared. The 5 is the base, and the 2 is the exponent. It sits a little higher up than the base. That's how we can recognize whether a number is an exponent. And it represents a number or a variable being multiplied by itself. So in this case, the number 5, which is the base, is going to keep getting multiplied by itself. The exponent tells us how many of the base is being multiplied. So since we have 5 is the base and 2 is the exponent here, we're going to multiply 2 5s times each other. So to simplify this, we could write it as 5 times 5, or we could simplify it all the way and say 25. Our first two examples have exponents that are positive numbers. So here we have 2 raised to the third power. We can read it as 2 cubed, and it really represents 3 2's being multiplied together. Remember, we take the base, and then the exponent tells us how many of that base we have and multiply them together. So in this case, we have 3 2's being multiplied. And we could simplify this even more by actually performing the operation of multiplication. So we have 2 times 2, which would give us 4, and then multiply that by the last 2, which would give us 8. So simplifying 2 cubed gives us 8. Now our next example has a variable as its base instead of a number, but the concept is still the same. The exponent tells us how many of that base we're multiplying together. So we're going to multiply 5 a's together. And we could write it out like this: a times a times a times a times a. And since we don't have a number to represent a, we don't know what a is equal to, we can't simplify this anymore. So we could just leave it like this. Next, we'll see what happens when we have the number 0 as an exponent. The main thing that you need to know about 0 as an exponent is that anything raised to an exponent of 0 equals 1. It doesn't matter what number or what variable you have as the base. If it's raised to an exponent of 0, that expression is going to be simplified to just 1 every time. So if we have 5 raised to 0, it equals 1. If we have b raised to 0, it also equals 1. So, pretty simple concept, right? Just need to remember, anything raised to 0 equals 1. But this is one of those concepts that's so simple that it's easy to forget. So make sure that you write it down so that you can reference it in the future. We can also have expressions that have negative exponents. The important thing to remember here is that when we're simplifying expressions with negative exponents, we want the answer to have a positive exponent. It's much easier to work with positive exponents when we're simplifying expressions and solving equations. So knowing how to use this skill of changing the negative exponents into positive ones will really help to save you some time when you're working with these problems. So our first example is 8 raised to negative 2. And notice we have the negative sign next to the 2 in the exponent. Our first step is to write this expression as a fraction. Any type of expression can be written as a fraction just by writing a 1 underneath as the denominator. So we'll do that. We have 8 raised to negative 2 in the numerator, and we just placed a 1 underneath as the denominator. It still represents the same expression, but just set up as a fraction. Our second step is to find the reciprocal of the fraction and then change the sign of the exponent. Now, in case you forgot, the word reciprocal also refers to the inverse of a fraction. The easiest way to think of it is that you're going to flip the fraction. So instead of having 8 raised to negative 2 over 1, we're going to flip it, and it will be 1 at the numerator and then the exponent part as the denominator. The second part of this step is to change the sign of that exponent though. Instead of having a negative 2, we're going to make it a positive 2. So let's see what that looks like all together. Here we go. We have 1 over 8 squared. Notice that the fraction is flipped and the sign of our exponent changed from negative 2 to positive 2. So remember, it's important that you not only flip that fraction, but you also change the sign of that exponent. So let's practice with a couple more examples here. Now we have 2 raised to negative 3. And here are our steps so we can refer to them. The first step is to write that expression as a fraction. So we have 2 raised to negative 3 over 1. And next, we find the reciprocal of that fraction by flipping it, and we change the sign of the exponent. So now we have 1 over 2 raised to positive 3. Now, we could stop here, but since the directions are telling us to simplify the expression, we want to make sure that it's simplified as much as it can be. So we can simplify that denominator more by actually figuring out what 2 raised to the third power is, which is 8. So by simplifying it, our final answer is now 1 over 8. For our next example, we have 1 over 5 raised to negative 2. So whenever we see that we have a negative exponent in our expression, we want to recall those 2 steps to help us to change this into an expression with a positive exponent. So our first step says to write the expression as a fraction. Well, our expression is already a fraction, so we don't have to change anything for step 1. Step 2 is to find the reciprocal of that fraction, so we're going to flip it and change the sign of the exponent. So our negative 2 becomes a positive 2. And it will look like this, 5 squared over 1. And we want to see if we can simplify this anymore, which we can. The numerator of 5 squared can simplify to 25. So now we have 25 over 1. And that can be simplified even more, because any number over 1 is like saying 25 divided by 1, which is just equal to 25. So this whole expression actually simplifies to a whole number. So just remember, sometimes you'll be given an expression that is already set up as a fraction. In that case, you just skip to step 2, where you find the reciprocal and change the sign of the exponent. Now we have an example that has a variable as a base. We have a raised to negative 10. We have our same steps. Whenever we see a negative exponent, we refer to these steps. First step, write the expression as a fraction. The same way as we did before. Even though we have a variable as a base, the process is still the same. So we have a raised to negative 10 over 1. And now for step 2, we're going to find the reciprocal by flipping this fraction and changing the sign of the exponent. So now we have 1 over a raised to the 10th power. And this expression can't be simplified anymore. We can't simplify a raised to 10 because we don't know what number a represents. So this is the most simplified that this expression will get. Now you might be wondering why these different laws work. Why does anything raised to 0 equal 1? And why is it that when we have a negative exponent, we can do that whole reciprocal thing and end up with a positive exponent? Well, here we're going to study the pattern of some exponent expressions that have the same base and see if we can understand where those different laws came from. So here we have almost a number line of expressions. Each expression has the same base of 3, but the exponents are different. Here we have positive exponents on the right side, +1, +2, +3 as exponents. In the middle we have the exponent of 0, and on the left we have the negative exponents, -1, -2, -3, set up in order just like a number line. Now if we simplify those expressions and see what they actually equal to, we get these numbers that you see right below them. We can use any of those properties, any of those laws that we just worked on, and be able to see that these would be the answers for them. But now we want to see why those laws work. Is there a pattern here? Well, if we start by looking at the numbers that have positive exponents, okay, we can see that there's a pattern of going from one number to the next number is like multiplying by 3. So when we start with 3 raised to the power of 1, it equals 3. And then if we increase that exponent to 2, 3 squared gives you 9. Well, another way of saying that is we just multiplied by 3. Because if we started with 3 and multiplied by 3, we get 9. The same thing for going from 3 squared to 3 cubed. It's just like multiplying by another 3. We start with 9 and multiply that by 3, and we get 27. So we could say that the pattern here is that as the exponent increases, we're multiplying by the base. Every time the exponent goes up by 1, we're multiplying by another of the base. Let's see what other patterns we can find here. Let's say if we go in the other direction. So say if we started with 3 squared and went down to 3 raised to the first power. The result of that is the same as dividing by 3. We will be starting with 9 and then dividing by 3 would give us 3. Okay? So every time our exponent goes down, we're dividing by 3. That helps us to understand why anything raised to the 0 power is equal to 1. Because if the pattern continues, we would start with 3 raised to the first power, which equals 3. And if we go down to 3 raised to the 0 power, we're dividing by 3. Every time our exponent goes down, we divide by 3. So that means that we would end up with 1 as our answer. Same thing if we keep going down by 1, keep decreasing the exponent by 1, we keep dividing by 3. So if our exponent starts as 0, we decrease it by 1, so now our exponent is -1. And now look what happens with the answers. We started with 1, and then dividing by 3 gives us 1/3. So every time the exponent decreases, we divide by that base. So studying these patterns can help us to figure out why these different laws, why these different properties that we learn in math make sense. So take a look. Do you see any other patterns here? Maybe you can come up with some properties of your own.